and it was very hectic last power electronics 2 periods.
When is your power electronic practical class?
Ma'am,
University model
day
practical.
order. That power electronics is like model like normal classes or day order 4.
So after control system only power electronics is coming.
Yes, ma'am.
Only two practical only you are having or
Ma'am,
any more?
girls and those who have PCB designing as a open elective, they have 3 practicals. One of PCB designing. Others have 2 only.
What is Vijayalakshmi ma'am teaching you? What subject?
Ma'am, which what?
Vijayalakshmi ma'am is teaching you one subject. It seems what subject
Machine, ma'am,
is
machine,
this
special
one?
machine, special machine.
For the whole class, madam is teaching you. Again, it is an elective.
Mm, Ma'am, it's elective, ma'am. Elective, ma'am. Like most of us are in like most like some 50% are in special machine, 50% are in solar photovoltaic. Divya Navamani, ma'am.
How that subject is split into two? Lavanya ma'am and Divya ma'am are sharing the subject on what basis?
And that we also don't know, ma'am. How they're like how
Okay, maybe half of the strength madam is taking and half strength Divya ma'am is taking. I think so.
no, I don't know, ma'am. Maybe batch one is Lavanya, ma'am, and batch two is Divya
Yeah, must
Navamani,
be like
ma'am.
that. Okay, anyways, we will start the class okay, rather than wasting time. Last class, what are the topics that was discussed? Just refresh the things now.
Like notch filter we discussed and second order active filter and that we just discussed like about tachometer feedback and introduction to unit 5 was discussed, ma'am. Only that state space model, nothing
Yes,
else.
yes, state space model is very important. Again, I told you. So, state space model is coming under modern control theory. Okay, modern control theory. This is coming under model control theory and how it is different from a conventional control theory aspect. So, in the previous units, we have discussed in your first unit conventional control approach only, that is transfer function approach we have discussed, but it is applicable only to linear time invariant single input single output system. Okay. This conventional theory is applicable only to linear time invariant single input single output system. But when it comes to state space modeling, the application is becoming broad. Like it can be applied to multiple input, multiple output system, linear or non-linear system, time invariant or time varying system. Okay, that way. So to what systems are these approaches applicable? Conventional means it is applicable only to LTIV SISO system. That is linear time invariant
Ma'am, your voice is like
single input single output
cracking
system.
like
But state
coming.
space modeling, my phone.
Ma'am, like
Why it
some
again?
part is coming then again mute and then it is coming like that it is.
Some sort of echo is there. Huh?
No, ma'am. Like it's cutting, ma'am. Like you are speaking, then again it's not speaking at all. Then again, like that. It's not clear.
Let me try. I don't know what happens. Let me check again. Okay. Okay. Okay, let me check whether again some problem is there. What about now?
Ma'am, it's not clear, ma'am.
I can't disconnect another device. I add other device only I'm pressing the but plug in the audio microphone into my okay. Anyways, now
Yes, ma'am. Now.
as I told you, conventional approach is applicable only for linear time invariant and single input, single output systems only. But if it comes to state space model, that is coming under model control theory, that can be applied to any systems, whether the system is linear or non-linear, and time variant or time invariant, multiple input, multiple output, single input, single output systems. So the application becomes broad. That is why people prefer state-space modeling for their applications. And already in my earlier class, I told you what is state-space modeling. Before doing that equation, one more thing I wanted to tell what is a state. Okay. So state definition is given by this paragraph. So what does it say? The paragraph. You are having any system. You are having any system. In that system, you are going to select a particular set of variables. Okay. So those variables will be called as state variables or state vector. And the status of that variables, let those variables be ranging from x1 to xn. So the nature of the variables at time t is equal to 0 and then t greater than or equal to 0. If you are able to have that knowledge, you will be able to determine the behavior of the system. So those variables will be called as what variables? Those variables are called as
State variables.
state variables. So any system you take, you are to select some variables in it. So those variables, the knowledge of those variables at time t is equal to 0 and time greater than or equal to 0, if you are able to gain means, with that knowledge you will be able to determine the complete behavior of the system. Okay, that is called a state variable. Right. Now next thing is state space model. Already I have taught you. So this equation is completely called as what equation? This
State
is
equation, dynamic
contributing your
equation.
state space model.
Model.
It is a combination of two equations I told you. What are the two equations?
State
State
equation
equation
and
and
output
output
equation.
equation.
So this is your state equation, this is your output equation, and I have already told you what is x, u, y, and x dot. So what is x?
State vector.
State vector. So x dot is first derivative of the state vector. Okay, u of t is your input vector, y is your output vector. Then a, b, c, d are some constant matrices. So a is called as your system matrix or state matrix. B is your input matrix, C is your output matrix, D is your feedback matrix. There are other names also given for it, but this is a common name. Okay, A is system or state matrix, B is input matrix, C is output matrix, and D is feedback matrix. This is an important equation that you need to remember. This might surely come in your MCQs. Okay, state space model. Now we will solve some problems on this. You will be given with one system or a transfer function or a characteristic equation from which you will be asked to determine the state space model. So let us discuss some problems based upon that. So here, this problem, you are going to obtain state space model using physical variable. Okay, so you know what are physical variables? What are various physical variables? Name some. What can act like a physical variable?
Time, frequency.
Force.
Time. Then only time is physical variable. The
Frequency,
system is what type of system that I am showing the slide? What type of system is shown in the slide? Electrical system. So this is an electrical
Electrical
system.
system.
So what are the various physical variables that are involved in an electrical system?
inductance,
Inductor
resistance,
What are
capacitance,
capacitor.
elements? What are variables? Inductance, capacitance are
voltage,
Voltage
values
and
are
current.
constant.
voltage,
Voltage and current. So this is my
Voltage,
variable.
voltage
I
and current.
is my variable. So voltage, current are some physical variables that we often see in an electrical system. Suppose if you consider a mechanical system means what are the variables that you are having?
torque,
Force,
Torque,
torque,
force,
Force, torque,
force, torque.
displacement. So
velocity.
those will be physical variables when it comes to a mechanical system. So you need to know how to develop a state space model using these physical variables considered as state space variables. Okay. So you have been given with one system, electrical system in particular, for which they have asked you determine the state space model. Okay. You know what is a state space model? What is a state space model? X dot is equal to AX plus BU.
BX,
Then
BU,
y is equal to CX
Y,
plus DU.
X,
You need to
BU.
form these two equations. Okay. So that is your given problem. So how you will do this is you will be just selecting some set of state variables. Okay. So what variables can be selected as your state variable? State variables that are selected are physical variables here for this system. So what are the various physical variables that I have told you?
current and voltage.
Current and voltage. Okay. Especially this is my output voltage. Okay, that is appearing across the capacitor, and the current. These two I am taking it as state variables. Okay, these two factors I am assuming the state variables that I have selected. Next thing is I have to apply basic physical laws and I have to write some equations. So since this is an electrical system, what physical laws can I apply?
Ohm's law.
Yes.
What? What law?
And
Ohm's
KVL,
law.
KCL.
KVL, KCL. So in what law can I particularly apply? KVL or KCL?
KVL.
KVL. So just I am applying KVL here. Okay. So using Ohm's law representation, I am going to write an equation. Sum of voltage drop is equal to sum of voltage rise. So what is the equation? The state variables that I have assumed are two in number. What are the state variables that I have assumed? X1 is I
IT,
and
X2
X2 is
is
V. Okay. So these are the two state variables that I have selected. So these are two state variables. Next thing is I am applying KVL and I am going to write one expression for this mesh. Okay, so what is the voltage rise that is present here?
P of T.
You know the difference between voltage rise and voltage drop components. So what is the voltage rise component?
E man. ET.
E of T is equal to what? What are the voltage drop elements?
Li plus Ri plus Ci.
Here you will be getting
LDI
L
by D.
di divided by dt and here Ri. Okay, the voltage here is V. Okay, so this will be equivalent to L into di by dt plus Ri plus V of T. Okay, so this is after application of KVL, I will be getting this equation. But what are the state variables that I've considered?
I and
In
P.
this equation, what are the state variables? What are the two state variables?
And current and
I
voltage.
and V.
I and P.
So here I am having I. Here I am having I, which I have designated as x1 or x2.
I as X1, V as
X1.
X2.
I is x1. Okay, so I have to replace those by x1 factor. Then what about v of t?
X2.
X2.
X2. So that I will be replacing it as x2. Okay, so that is what I am going to do. So if I do that, that is one equation that I have written. E of t minus v of t minus ri of t is equal to L into dA of t divided by dt. Okay. Now I know how to write I of t. I of t I have considered as what variable? State variable number 1. This can be written as x2, okay, because v of t I am assuming it as x2 minus r into x1, divide the whole thing by L, because this L term I am bringing to this side. So in this side I will be having dx1 divided by dt. Right or wrong? Understood this step or not?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Now, how can I represent this dx1 by dt? That is one-time derivation, differentiation of what factor?
X with respect to T. Current with respect to time.
x1. So you can write it as x1 dot, yes or no?
Yes, ma'am. Absolutely.
x1 dot,
Yes, ma'am.
that is equal to 1 by L into minus, okay, minus r by L into x1 minus 1 by L into x2, then plus 1 by L into E of t. Yes or no? Understood? How I have rewritten the equation, have you understood?
Yes, ma'am.
So this is my state equation number 1. Okay, state equation number 1. This is because first derivative of the state vector x1 dot. Similarly, I need to find out, I have chosen one more state variable. What is the other state variable that I have chosen?
X2.
X2. For that also I need to do the first differentiation. So this is my first state equation. Okay. So one more equation is also possible for me to write as per this circuit. So what is the output voltage here? It is appearing across what? V of t, that is my x2 second state variable, that is equivalent to voltage across the capacitor. Yes or no?
Yes, ma'am.
Okay. So how can I write the voltage current relationship for a capacitor? Voltage current relationship for a capacitor.
Q equals to CV.
P dV by dt equals to I.
C dV by dt is equal to I of t. Okay, so again, this I of t is my state variable number 1 or state variable number 2? I of t is x1 and V of t is
X1.
x2. So do the replacement again. Okay, so C into dx2 by dt, which is equivalent to my x1. And now already I have found out what is x1 dot. Now I need to find out x2 dot. So how can you do that? By using this equation only. So how can I write dx2 by dt?
Ma'am, C by dt. No,
This
C.
can also
In
be
case of
written as
C, it becomes
cx2
x2.
dot, which is equivalent to x1. Right or wrong?
Yes, ma'am.
Okay, so then finally my x2 will be equal to 1 by c into x1. Correct? So I got my state equation number 2. Okay. With that I can write the state model plus one more output equation I have to write down. So what is my output here? Again from the circuit diagram,
V,
Voltage.
the
ma'am.
output voltage is
V voltage.
x2, that is equivalent to my what?
Capacitance drop.
So this, let it be
Voltage.
y is equal to x2. Okay, because this is equivalent to v of t. So y is equal to x2. This is my output equation. So I have got state equations, output equations. Now finally I have to obtain the matrix representation. Okay, that will be a complete state space model. So remember this equation, and this equation. Okay. With that only I will be writing out matrix. So I am writing state equation, that is x1 dot x2 dot, that is equivalent to, I have to indicate A matrix x1 x2. This is my B matrix and this is U, that is my input. Okay. So now what are the coefficients you have to tell me from the two equations? Coefficient of x1 here is what?
R and minus L. Minus 1 by L.
Minus R by L. Okay, here you are having minus R by L x1. So what is the coefficient of x2?
Minus 1 by L.
Minus 1 by L. Okay. Plus E of t is my input. So what is the coefficient for it?
Plus 1 by L.
1 by L. Okay. So based upon this equation, I have written first state equation. Now again, the second state equation is this one. So what is the coefficient of x1 here?
1 by C.
1 by c. Okay, what is the coefficient of x2? Is there any
1.
x2 term?
1.
No, ma'am.
0. Okay. What about the input here? Input E of t is present in there? No. Okay, so here
No,
also you will
ma'am.
have 0. Okay, so this equation is called as what
No,
equation?
ma'am. 0.
This equation is
State
called
equation.
as state equation.
State equation.
Okay, understood now all of you. I want to hear response from everybody.
Yes,
Yes,
ma'am.
ma'am.
State
What
equation.
about the rest in class? Prince, Pratyush, Purushottam, Pushpesh,
Yes, ma'am.
Raj, Shivanshu, Shivam,
Yes,
Shrestha,
ma'am.
Shivam.
Yes, ma'am.
Then all the girls also understood the concept, how I am deriving state equation and output equation. Alusha, Aditi, Deepalakshmi. All of you understood or not? Bharadwaj,
Yes, yes, ma'am.
Yes, ma'am.
Chandramal. Okay, now how I will write the output equation? Y is equal to x2. Okay, this is my output equation. So y is equal to, again, x1, x2, because the rest is 0 here. So what is the coefficient of x1? This is my equation from which I have to write the matrix. So what is the coefficient of x1?
And minus R by L.
This equation I have to write it in terms of matrix. So matrix I have written. So what is the coefficient of x1? Does it have any x1
0.
term in there?
Zero, ma'am. Zero.
So what about x2 coefficient?
1.
1. Okay, that's all. Alright. So let us check out whether this is correct or not. Okay. So what is this equation called as?
State equation.
State equation. And this equation?
Output equation.
output equation. These together will be called as what?
State space equation.
Dynamic
State
equation.
space
Yeah, already
model.
state space model.
Okay, now you understood what sort of problems will come based upon this topic. They will give you any system. Okay, it's a
హాస్పిటల్ కి
electrical
బాబాయ్
system
వస్తున్నా
or mechanical system.
హాస్పిటల్ బాబాయ్ వస్తాడా
What
హాస్పిటల్
Aniket?
కి బాబాయ్ వస్తాడా అడుగుతున్నా ఆ డాడీని లడ్డు
Aniket?
ఇచ్చేసామన్న అట్లనే బాబాయ్కి
Aniket, mute your mic. Okay, so they will be giving you one system which may be electrical system or mechanical system or any other system for which you have to pick some selected number of state variables. Here we are picking out physical variable in the form of voltage and current. So you have to use some basic physical laws. Then you have to write some equation. You have to reframe that equation with the state variable, and you have to form the state space model. Understood this concept? Shall we proceed to the next problem?
Yes,
Yes,
ma'am.
ma'am.
Okay. So here comes what type of system now? Earlier
Mechanical
discussed
system.
electrical system, now mechanical system. So same way you have to form the state space model by selecting some set of state variables. Okay. And you have to apply the basic physical laws to write down an equation, differential equation. So what law here you will be applying?
Work energy theorem.
Newton's second law of motion. So you know how to derive. This is a mass spring damper system only. Okay, which is being applied with this some force. So you know what is the equation that you will be having. That is equivalent to m into s squared into x of SR. F is equal to m into
dv by dt.
dt squared. But here the displacement is given in terms of x or y. Force.
Ma'am, y.
What is the displacement notation?
Why? Why?
Y. So you will write it in terms of y only. Then complete the equation. You know the equation. M d squared y by dt squared plus b into dy by dt plus finally k into y. You know how to derive these equations from your first unit. Do you remember or not?
Free body diagram, ma'am.
What?
Yes, ma'am.
Swaraj?
ఎస్ మ్యామ్
Ma'am, simply from free
Okay.
body diagram.
So this is the equation that I have derived by applying the Newton's law onto a mechanical system. Now next thing is I am going to assume some state variables. So what state variables here they have assumed?
X1, X2.
So what they have assumed here?
Ma'am,
These
position
are the
and
two state
velocity.
variables. X1 is assumed to be equal to what?
Position.
That is
No.
displacement.
Yeah, position. Displacement and velocity.
Okay, y is assumed, that is displacement is assumed to be state variable number 1. Okay, then dy by dt, that is first differentiation of the displacement is assumed to be what?
Velocity.
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 That is second state variable. Okay, so x1 is y, x2 is one time differentiation of displacement. Okay, velocity in your case. Okay, now these are the state variables that I have assumed. Now I want to obtain the state space model. So how will I do that? Tell me. I want to obtain x1 dot and x2 dot. So how can I obtain that? And input output also I have to get. Okay, so how I will be able to do that? X1 is y, so I have to get an equation which is having dy by dt. So what is x1 dot?
Y dot.
X1 is y. I want x1 dot, so that is equivalent to dy by dt. That is equivalent to x2.
X2.
Okay, so what is x1 dot? That is
dy by
equivalent to
dt.
x1 dot is equal to what?
x2.
x2.
x2 now.
Okay, so I have got derivative of first state vector. Now I need to determine x2 dot. So how I will do that? From this
x1
equation.
double dot.
x2, yes.
Okay, so
Oh,
just
why?
I will want to find out this one. Okay, so what is this one equivalent to? From this equation, f minus b into dy by dt minus ky. Okay, again I have to simplify. How can I write this dy by dt? dy
y
by
dot.
dt is what?
Y dot.
x2.
x2.
x2, yes, x2.
Okay, so y is x1. Okay, now how can I write d squared y by dt squared?
Y double dot or x2
One
dot.
time differentiation is
x2
x2.
dot.
So this you can write it as x2 dot. Yes or no?
Yes, ma'am.
Okay, now you write the equation. Okay. Now x2 dot is equivalent to, now tell me the answer, minus b by m x2 minus k into x1 plus f divided by m. Correct?
Yes, ma'am.
So this is state equation number 2. This is state equation number 1. Okay. So with this combination, I can write the matrix representation. State space model I can write. Let me check what they have did. Okay. Is it correct? Okay. From that equation, let us check back the equation again. So what is the coefficient of x1 data, or how I can write x1 data? This equation and this equation I have to combine and I have to write it as state matrix. Okay. So what is the equation? Again you tell me. x2 dot is equal to f by m minus v by m x2 or x1?
X2.
x2 then minus k by m
X1.
x1 now. So x1 dot is equal to x1 dot is equal to x2
x2.
no x2. Okay, and one more thing. Now what is y? Y is output equation. That is your displacement. You are applying force and you are obtaining the displacement as the output. So y is equal to, what is y?
x1.
When you are applying force, the output is your displacement that you assume to be, that is y actually, that is you are assuming it to be the first state variable. So what is y? Y is equal to x1. This is your output equation. Okay, remembering this. So this you are to convert into matrix representation. Is it okay or not? Here comes your first derivative of state vector x1 dot x2 dot, and this is your state equation. This is your A matrix, system matrix, which you will be denoting the coefficients of x1 and x2. So from this equation, what is your coefficient of x1 and x2?
And coefficient of x2 in x1 dot is 1.
Coefficient of x1 is 0. Okay, coefficient of x2 is 1.
1.
Okay,
Ma'am, but there
correct
is
or not?
a
Huh?
Yes, ma'am.
Correct or not?
yes, ma'am.
Okay. Then from the next equation, from this equation, what is the coefficient of x1?
So minus k
What
by
is the coefficient of x1?
Minus k by m.
Minus k by m. What is the coefficient of x2?
1. B minus b by m.
What is the coefficient of the input? Input is force. So what is the coefficient of input?
1
1
by
by
m.
m. So minus k by m, b by m, 1 by m. So this is how you'll be forming state equation. Okay. And we know output equation is equal to x2. Okay. From that you are deriving this equation. Output equation. Okay. This combinedly together will be representing what is the name of that model?
State space model.
State space model. Okay, if you want to, if you have been asked to draw the block diagram representation using these equations that you have done, you can draw the block diagram. That might also be asked rarely. The output here is y is equal to x2 actually. They have written it wrong way. Okay, or x2. Alright. Right, applied input is force here. Output is displacement. So using these equations only, they are drawing this block diagram. If you closely look into the diagram, you can correlate that with the equations written. Okay, this representation is equivalent to what? That you know, no? What is that equivalent to? Block
Integrated block.
integrator.
Integral.
So if you are integrating x2 one time, you will be getting x2. Okay. Then again, if you are integrating x2 one more time, like that, it will go on. Okay. If you want to write down the expression for x2, it is the sum of this term, and this term. Okay, that you have obtained from this equation only. Okay, so you can relate these equations to the block diagram. Okay, this is another problem. Next. Again, you have been given with what diagram?
Electrical system.
Same. The first problem we have seen, same problem only here they have given. Okay, RLC circuit. So I don't want to describe this. Now, example 4. Okay, they have asked you to do what in this example?
Differential equation.
You are being given a good system 24 divided by s cube plus 9s squared plus 26s plus 24, for which they have asked you to determine the state space model. Okay, described by the following differential equation they have given. Okay, this differential equation is nothing but the characteristic equation. Okay, all right, you can check it out, isn't it?
Yes, ma'am.
So now again you have to choose some set of state variables. Okay, so they have chosen state variables. In third order, so they have chosen three states. So what is chosen as the first state?
Ma'am, C.
C. C is chosen as the first state. Then one-time differentiation dx1 by dt, that is equivalent to dc by dt, which is equivalent to x1, sorry, c dot, that is equivalent to
C dot, ma'am.
x1 is
Equivalent
equal
to
to x2.
x1 equals to C.
Okay, c dot is equal to x1 dot is equal to x2. That is the second state variable they have chosen. Now, three-time differentiation, two-time differentiation of c dot, double dot, they have considered as a third state variable. Okay, d squared c divided by dt squared, they have considered as a third state variable. Okay, so this is how they have chosen state variables for this particular system. And the output equation they have considered as usual, y is equal to c is equal to x. Okay. Now x1 is c. Okay. What about x2? X2 is one-time differentiation of dc by dt, that is dx1 by dt. So x2 can be written as what?
X1 dot.
x1 dot. Okay, now the same fashion how x2 dot is written.
x3.
This one time differentiation if you do means that will be x3. Okay, so that is how you got this equation. Okay, now you are to apply all these in this equation. Okay, so how can you do that? Tell me. You understood the
Substitute.
concept of the choice of the variables.
Yes, ma'am.
Now you have to apply this in this equation. So how the equation will be changing? What is C triple dot? C double
Ma'am,
dot is what?
C double dot is x1.
C double dot
X3.
is x3. So C
X3.
triple
x3,
dot
sorry.
can be replaced as x3 dot. Understood?
Yes,
That you
ma'am.
want. So bring the other terms to the other side. So 24, R is input. Okay. So you can write that as U. Output is C. Okay. Next, what are the other changes that you have? Minus 9. How can you write C double dot?
x3.
X3 plus 26. C single dot.
x2.
Then C
x1.
x1. So this is how they got this equation. So you have got what is x1 dot, you know what is x2 dot, you know what is x3 dot, you know what is y. So easily you can frame the state space model. So tell me what is the state space model that you will have. I will write the equation. You have to have x1 dot, x2 dot, x3 dot. This is your matrix. x1, x2, x3 uh, plus B matrix. Tell me what is the coefficient. x1 dot. What is x1 dot? See, this is a basic concept. That is why I'm going very slow because you won't understand sometimes because of the double differentiation, three times differentiation, how we are making that equal to state variables. You will not understand. That's why I'm going very slow. If you are not
Then
able to
zero
understand
one
this
zero.
basic concept, the whole unit is full of state space model only. Come on, what is x1 dot equation?
Ma'am, 010.
0101.
This equation only. What is the coefficient of x1? x1 is 0. x2 coefficient is 1. x3 is not there, so 0. Similarly, from this equation, what is x2 dot?
001.
001.
0, 0, 1. What about x3 dot from this equation?
24 minus 20. Minus
Minus
24 minus
24.
26 minus
Minus
9.
26. And minus 9.
9.
Okay, and one more input.
24.
This is 0, this is 20. 0, 24.
Zero
So
zero
this
20.
is equation that is called as what equation?
State equation.
What is the name of that equation?
State equation, output equation, together state space model.
State equation, ma'am.
What about output equation?
Ma'am,
This
0020.
equation will help you in creating output equation. So y is equal to again x1, x2, x3. So what is the coefficient? Refer to this equation. So what coefficient? Y is equal to C is equal to x1 only. Okay, so 1, 0, 0. Okay. So both combinedly it will be called as SS model.
Ma'am, why I did
That is
not
the first
understand.
answer. So this is the equation. Okay, state space model. All of you understood? Huh? So you have been given with one electrical system, you have been given with one mechanical system, you have been given with one difference equation, okay, from which you have been asked to derive the state space model. So first thing is you have to apply basic physical laws, you have to select some selected number of state variables, you have to apply that in the equation, you have to frame the state equation and output equation combinedly called the state space model. That is what you are going to do. Okay. One more example we will discuss. With that, we will find out. Understood or not? With this, shall we close the class?
Yes, ma'am. Yes, ma'am.
Okay, this is only one portion of problem that might come from this unit. Still, you need to know
Ma'am,
several
that
other options.
output equation will be given in the question.
No, it will not be given. You have to, with the help of the state variable, you have to assume.
Ma'am, output equation we did not understand.
Output equation did not understand, I guess.
No output equation will be given.
Ma'am,
Okay,
how
you
you
know
got
from
y is
you
equals to
know
c is
from
equals
this y is equivalent to c. No,
to yes, ma'am.
that you are assuming it as x1. That's all. Okay. If it is an electrical system, means you know what is output. Input is force, output is this displacement y1, y2. So here you will be getting two, 1, 2 plus 2 or something like that. These two will be combinedly forming output equation. Now understood?
Matrix formation, ma'am. Output equation.
Yes. Okay. So depending upon the system only you will be deciding outputs. Okay. Suppose if that is an electrical system, E naught is your output. Okay, that is the voltage appearing across R and C series combination. You will write one equation and based upon that you will write Y. Understood now? Yes sir, no ma'am.
Yes, ma'am.
Yes, ma'am.
This equation. That is what equation? Y is output. Okay. So using that only they will form the matrix. Understood now?
Yes, ma'am.
Yes, ma'am.
Okay, that's all for today's class. I'm hoping all understood. Okay, so basically you will be given with one system. The system may be a figurative representation of electrical system or a mechanical system, or it may be a transfer function, okay, or it may be a characteristic equation, a difference equation. From that you have to obtain finally state space model. State space model is a combination of two set of equations. What are the equations again?
State equation and output
State
equation.
State
equation
equation
and
and output equation.
output equation. Okay, that's all for today's class. Okay, we'll discuss the rest of the topics in the next class. Okay. See, and I forwarded that last experiment for you in this year. Okay, today lab class will be state space model only. Okay. All right, all good in this bus. I'm hoping all of you understood.
Yes, ma'am.
Yes,
What
ma'am.
about girls, Bharti, Brinda, and all? You understood?
Yes, ma'am.
All can discuss.
Thank you, ma'am.
Okay.